as we talked about last session,
Mhm.
two of the most important things you can do in geometry are being able to solve right triangles. Okay?
Mhm.
Now,
Okay.
most of the time, when you encounter a right triangle, they're going to give you two of the sides.
Okay.
So the goal is always to solve for the third side. Now, occasionally they're going to give you triangles that are either 30, 60, 90, and they're only going to give you one side.
Okay.
Those
Yeah.
are the ones we have to use our unit special triangles for.
Okay.
For a minute here, I just want to go through the math on solving right triangles. Solve
Okay. Sure.
for that. And I'd like
Okay.
you to do it directly. In other words, I really want you to memorize how to do it directly. By that I mean, I don't want you to have to always go back to the Pythagorean Theorem. Here, I will write the Pythagorean Theorem.
Okay.
Okay, that's the fundamental thing everybody starts with. But the
Mhm.
problem is if you start with this and have to go through the solution, there's just too much math to do. I mean,
Yeah.
it's slow. So understand how to solve for the hypotenuse. That's what C is, the hypotenuse.
Okay.
So let's start with this first one.
Okay. Um. All right. So. Well, so you said like with the Pythagorean theorem, it's just too much math.
Well, no,
So.
I mean, if you can't
Yeah.
do it any other way, always start with the Pythagorean theorem.
Okay.
But what
What would
what
another
you're
way
going
be?
to find is that there's really only two things you really have to memorize, and that
Mhm.
is, what is the hypotenuse? If a squared plus b squared equals c squared, then what is c equal to?
C is equal to. Uh.
How do you solve this equation?
You do like 5 squared plus 7
Hold
squared
on.
equals.
First solve
Okay.
the equation. I want to get to the equation that I want you to memorize.
Oh, okay. Um, so for the one on the top, you would,
Solve that for c. How do you solve that for c? This is
um,
just basic algebra.
yeah, so you could subtract b squared from both sides
No,
first.
no, no. You're solving for c. You're trying to isolate
Oh,
that c right there.
yeah, so you just divide by c squared.
No, that would give you 1.
So just,
You could divide by c, and
oh, okay,
that
yeah,
would
so,
leave c, but then you have c on the other side, and you can't do that.
no.
When you're solving an equation for a variable,
Hmm.
your goal is to get it all by itself and none of it on the other side. So
Okay,
dividing both sides by c here doesn't solve for c. But
no.
what would?
Um, what would solve for c?
What's
You could find the
what's c?
square root of
There
c.
you go. In other words,
Okay.
what is this 2 doing?
It's squaring c.
Okay, so we want to do the opposite.
Yeah.
Take the square root.
Okay. Okay.
This is what I want you to memorize
Okay. Yeah.
so that you can go directly to it. In other words,
Okay.
c, which is the hypotenuse, and only the hypotenuse is this.
Mm-hmm.
Now let's solve for one of the short sides. In other words, in this example in this example here, we have the
Mm-hmm.
hypotenuse and one of the short sides. So let's
Yeah.
solve for the other short side. What is and we'll call this short side. We don't care if it's either short side.
Okay.
In other words, how do I solve this equation for A?
For A, you would just multiply A by SS,
What's your goal in solving equations?
isolating
A.
the variable you're trying to. Yeah.
Okay. So
Okay.
what's currently on that same side of the equation?
SS.
Where are you getting S? No. I'm talking.
Where are we look?
I'm talking up here.
Oh, you. Oh, I'm sorry.
That's
I
up
was looking at the one all the way down there.
We're
Yeah.
getting SS. Well, that's where we're going to write our answer. But
Oh, okay.
to start with, solve for A. What are you going to
Okay.
do first?
You would subtract b squared from both sides.
Okay, so you have C squared minus B squared. And then what?
And then, so once you get that, you would, so it'd be c squared minus b squared is equal to a squared.
Okay, so now what? How do you solve for A once that happens?
You can divide by a. Well, no, you can't. You would find the square root of a squared.
Okay. Yeah.
Yeah,
Okay.
exactly.
So these two down here are all you need to know.
Okay.
In fact, you could probably go the rest of your life without knowing the Pythagorean theorem.
Cool.
Okay, well, no, I mean, I'm saying that only in half
Yeah.
the test. Because if you knew these two down here,
Then you wouldn't really need to use the.
right, I don't need to ever go back to the beginning. In other words, these two, notice, solve for whatever the missing side is.
Okay.
If I'm missing the hypotenuse, this one solves for it. If I'm missing one of the short sides, there's two short sides to every right triangle, and if I'm missing one of them, then this is the way you solve for it.
Okay.
Okay?
Uh-huh.
All right.
Yeah.
So this is what I would like you to use when you're doing these problems. Not go all the way back to the Pythagorean theorem. There's just too much math to include. Now, notice one thing. That when I'm solving a right triangle, my answer always starts out with square root of.
Okay.
It could be the square root of a perfect square, which means it'll turn into a whole number. But most of the time, the mistake that most students make is they leave off the square root. If they're solving for C, they want to take a squared plus b squared instead of taking the square root of a squared plus b squared. So always know that your answer, no matter which of the three sides you're solving for, is always going to begin with square root of.
Okay.
So in problem number 1, what is x equal to?
X is equal to 5 squared plus 7 squared.
What did I say your answer always needs to start out saying?
Square root of 5 squared plus 7 squared. Yeah.
Okay, and that is the square root of 25 plus 49. What is that, 74?
Yeah, 74.
Okay, so that's
okay.
the answer. Now,
that saves so many steps.
Well, it's just
it's much easier.
This is a task that you have to do so often. I'm telling you that if you can master solving right triangles like this, and solving a right triangle when it's a 30, 60, 90, or a 45, 45, 90, and they only give you one side, that's a little trickier because you have to use similar triangles. In other words, this has nothing to do with similar triangles here. This is solving right triangles. So what's x in this one here?
So for that one, it would be x is equal to the square root of 2 squared plus 8 squared.
Notice that when you're solving for a short side, subtraction is always going on in the middle.
That's right. Yeah.
And it's always the hypotenuse first. Because if you switch these up, you'll get a negative number. So if you start with negative numbers, know you've done it backwards.
Yeah. Okay.
So what is this?
So that would be x is equal to 2 squared minus 8 squared. Or 8 squared minus 2 squared. Yeah, there we go.
And it makes a difference. If I did 2 squared minus 8 squared, I'd end up with a negative number.
Yeah. Okay.
So that's 64 minus 4. Square root of 60.
Mm-hmm.
Square root of 60 be simplified?
Uh, can it? Well,
Well, here's what you do to figure out. You start
yeah.
going through your perfect square numbers.
Okay.
It doesn't matter whether I can divide it by 5.
No.
In other words, I could separate it into 5 and 12, but neither of those two are perfect square numbers.
No. So I don't think you
Perfect
can.
square numbers. Well, hold on.
Mm-hmm.
Let's list our perfect square numbers. 1,
Okay.
4, 9, 16, 25, 36. You see where I'm getting these?
Uh-huh.
It's a very important list to memorize, to know your perfect square numbers.
Okay.
That's 1 squared, 2 squared.
Yeah, I see. Yeah.
Okay. This
Yeah, I see.
is simplifiable if one of these perfect square numbers is a factor of that. In other words, if I can divide 60 by 4, I can simplify it. If I can divide it by 9, I can simplify it. 16, 25, 36. Well, obviously none of these are going to work, but I can. And usually if you can divide by 4. For most radical numbers that can be simplified, always start by looking at 4, because so many numbers are divisible by 4. So,
Okay.
calculator, see if 60 is divisible by 4.
Let's see. Um, yeah, 15.
Okay, so that's equal to the square root of 4 times the square root of 15.
Mm-hmm.
And now, because that's a perfect square number, I can turn it into a 2.
Square root of 15.
Right. Now,
Okay.
notice that 15 is divisible by 5 and 3. But I never do that because neither one of those converts to a perfect number.
No.
And as all I've done is turn one term into 2 terms. So I
Okay.
do this, and you shouldn't do that. You only reduce it down to whether you have pulled the largest number possible out of that as a perfect square number.
Mm-hmm.
Okay? So
Okay.
that answer is 2 root 15. In other words, you would never see that as if it was a multiple choice. They're not going to put root 60 up there.
No, definitely not.
So you have to be able to simplify these, and that's a big step because notice all of our answers are going to be square root of something.
Yeah.
So being able to simplify radicals is huge
Okay.
in terms of mastering this stuff.
Mm-hmm.
What's x in number 3?
Number 3. Okay, so it'd be x is equal to the square root of 3 squared plus the square root of 7.
Squared.
Squared, yeah.
Make sure you do every step.
Okay.
Just because
Yeah.
it's something strange looking, like a radical, doesn't mean anything. You just have to square it.
Okay.
Now, what does that simplify to? What's 3 squared?
9
What's square root of
plus
7 squared?
the square root of 49.
No, that would be 7 squared.
So
Well, no,
would you just
actually you're right. You said it right. But what is the square root of 49?
7.
Okay, so that's what goes there.
Okay.
In other words, anytime you take the square root of x and you square it, you get x.
Mm-hmm.
Notice what this is. This is x to the 1/2. That's the square root of it. And then I'm going to square it, which means I multiply those two together to get x to the 1. Okay? But basically, what you need to memorize is that any number, square root of 17 times the square root of 17 is 17.
Uh-huh.
Okay? So, this is square root of 16, which changes to a whole number. So that side is 4. Now, observe something interesting here.
Mm-hmm.
If I said I have a right triangle and two sides are 3 and 4, what would you be inclined to say was the third side?
5.
Right.
Right? Yeah.
But it's
2, 4,
only
5.
true if the 3 and the 4 are the short sides. In other
Yeah.
words, if I have a 3 here and a 4 there, that one's definitely 5. But if I have a 3 here and a 4 there, notice that's not 5.
No.
That's one of the short sides. So the 3, 4, 5 triangle has to be in the right proportion.
Mm-hmm.
In other words,
Yeah.
the 3 and the 4 have to be the two short sides, or the 5 has to be the long side. And in fact, if I said, can you solve for x and y? That's a right triangle.
Okay. Well, could you do... Ooh. Could you do y squared plus x squared is equal to 5?
You can, but that's not
Okay.
going to let you solve for x or y.
Yeah.
Right? Because that's going to give you an equation with two variables.
Yeah.
Okay.
Um.
The answer is no, you cannot.
No, you can't, yeah.
No. In other words, you might be inclined to say, well, x has to be 3 and y 4, or y has to be 3 and x 4. And
Yeah.
there certainly be some logic to that thinking, but examine how I might draw this thing. I could make my 5 go from there to there.
Okay.
Whereas I haven't changed the length of my hypotenuse, but I've lengthened x and I've shortened y.
Yeah.
Which is all that tells me is that I have an infinite number of solutions. I could have many, many combinations of x and y, because I could go up here and steepen that thing also, so that it's still 5 units in length, but now I've lengthened y and I've shortened x.
Okay.
So, in other words, much like algebra, when you have two variables, you usually cannot solve for them if you only can come up with one equation.
Okay.
All right.
Okay.
So, these two memorize. Now, that one's fairly straightforward because you know the Pythagorean Theorem.
Yeah, for sure.
You know that a squared plus b squared is on one side. So it doesn't take much to come up with this one. You just take the square root of both sides and you have this. This one's a little tricky because it requires subtracting the b squared first and then taking the square root of both sides. But just remember that you always have the hypotenuse squared minus the other short side squared. Okay?
Yeah. Okay.
All right.
Alright, cool.
Now, not to beat a dead horse, but just because it is the same rationale, now I'm going to give you some triangles that I'm only going to give you one side.
Okay. Cool.
But it's a 30-60. And there's only two special triangles I can do this with. I can give you only one side and expect you to be able to solve it only with these two triangles. Okay? So, let me throw in some numbers here.
Sure.
If that's 4, what are the other two sides?
So if that's 4, it would be, let's see.
Now, in order to know this answer, you have to know what your two unit ones are.
Yeah.
Tell me the dimensions of this unit little one up here. What's the...
that'd be 1. The bottom would be the square root of 3, and then the hypotenuse would be 2.
Okay, so if you start there, you're not going to go wrong.
No.
In other words, don't try to solve this all in your head. You don't have to.
Okay.
In other words, as long as you can create this triangle, then you can solve this.
Mm-hmm.
Now what?
So we know R of L would be 2 over 1,
Where are you getting 2 over 1?
or just 2.
No, what you have to do is compare corresponding sides.
Okay.
How much bigger is each side of this triangle compared to this triangle?
4 over 1.
There you go. That's all you have
Okay.
to do. It's really
Okay.
simple. You just have to find the side that's the corresponding side. This is the side opposite the 30-degree angle. This is the side opposite the 30-degree angle. So at no point am I comparing this number with this number, or this number with this number. I'm always comparing numbers between the two triangles.
Okay.
Okay? So we'll say the ratio, the linear ratio is 4 to 1, and that's big to small.
Yeah.
What's that equal?
And then that would be so if it's 4 over 1, you would do, so you could do 4 over 1 times, would we just do times 2? Like to find the, okay,
What
gotcha.
this linear ratio means is that every corresponding side on this triangle is 4 times bigger than its corresponding side over there.
Okay, yeah.
So what's this side down here?
And then so it'd be 4 times the square root of 3.
Yeah, just say 4 root 3.
Okay.
But you don't need to say times. When I write it 4 root 3, it means times. It's like not needing to say 4 over 1. You could have just said the linear ratio is 4 times. You know, there's nothing wrong with 4 to 1. But,
yeah.
Okay, now let's solve this triangle over here. And that requires you to draw upon your memory as to what the dimensions are of the unit.
Okay. So for that one, it would be on the left side 8, and then the bottom 8.
Hold on, let's do the unit first.
1, 1. Okay, so it'd be 1, 1, square root 2.
Okay, cool.
Cool.
Now, erase this one. That's out of the picture.
Okay.
Only dealing with these two over here.
Okay. So we know that R of L is root 2, or square root of 2, and then square root of 7.
Go big to small, always.
So square root of 7 over square root of 2. Okay.
Excuse me. I meant to write a 7. My hand wrote 2, though.
No problem.
Okay. Now, that's a number that has an irrational denominator. And at some point, we're going to have to rationalize it. In other words, before I write answers here, I got to have to rationalize it. So we kind of have a choice. We could write it first and then rationalize it, or rationalize it first and then do the multiplication. I kind of think that never rationalize until you're at the end. There's nothing wrong with that number. That's a perfectly good number. That will give you the exact same number in your calculator as if you rationalized it.
Yeah.
Okay? So let's wait until the end to rationalize.
Okay.
Okay, what's that?
So that one would be, okay, so we could do the square root of 7 over the square root of 2 times 1. So it'd just be square root of 7 over square root of 2 for that one.
Yeah, now I'm going to have to rationalize it because now I kind of have a final answer. What about this side over here?
That side would also be the square root of 7 over square root of 2.
Let's rationalize it first before we write that.
Okay.
How do I rationalize that?
Let's see. How would you rationalize it? Just square root of 7 or square root of 2.
In other words, the thing about all of these geometry, these right triangle problems,
Yeah.
is they require you to know the Pythagorean Theorem, and they require you to know how to simplify all radicals, and they require you to know how to rationalize denominators. If you can't do all four of them, you're not going to be able to solve most of the problems you come across.
Yeah.
Okay? So, this is part of one of those four things. You've got to be able to rationalize denominators.
Okay.
I can multiply any fraction by the number 1. What do I want my 1 to consist of here?
Well, 1 over...
What will turn the denominator into a rational number?
Just 1.
No.
Well,
multiplied by 1
no.
would remain square root of 2.
Yeah, so you could... Well, you could do 2, and so you could get...
Multiply it by 2, it becomes 2 root 2.
Not 4. So...
You're close, you're getting closer though. What if I multiply it by square root of 2?
Oh, okay.
Now it turns into 2.
Yeah.
That's a rational number.
Okay, that makes sense.
What do I have to multiply the top by?
3.5, well, root 7 you could do.
Then I have not multiplied that fraction by 1. I've now multiplied it by a number greater than 1.
Yeah.
Can't do that. That would change its value. If I multiply any number by another number that's not 1, I'm changing its value. 1 is the only thing I can possibly do. So what does the top have to be?
So the top would have to be... So it'd have to be... Okay.
What makes that 1?
2. Square root of 2.
Square root of 2.
Yeah.
There you go. Now I've multiplied it by 1, which means I haven't changed its value. But what do I get now? What's the square root of 7 times the square root of 2?
Square root of 14.
And what's square root of 2 times square root of 2?
1. Wait, square root of 2 times the square root of 2? That would be just 2.
And there's your answer.
Okay, that makes sense.
So that's an acceptable answer. Because it has a rational denominator.
Okay.
I'm going to change that one also.
Okay.
In other words, if you don't know how to do this last step, you're not going to get these problems because you're not going to see this as an answer on a multiple choice test. Ever.
No.
You would see this, but not this. So if you don't know how to take that final step, it's going to impact your results tremendously.
Okay.
So you have to know you're very, very close. You are. You're very, very close to being able to do all of these right angle problems. But if you can get 100%, you will be amazed at how good that helps you on the ACT exam. Okay. I'm not sure it'll help you next semester in geometry. I'm not saying it won't. But the primary place it's going to help you is in any of these tests that have geometry in them. So much of the geometry are solving right triangles. All right.
Okay, cool.
So I'm going to keep on that, at least until school starts, until you get absolutely expert in it.
Sure, yeah.
But for today, let's go on. Because part of you getting expert in it is being able to do it not just now, but tomorrow, and then the next day, and then a week from now.
Yeah.
You know what I'm saying? In other words, learning, it's not going to do anybody any good if you can only do it right now. In other words, I'm sure I could put a lot of right triangles up there and you could solve all of them right now. I don't have any
Mm-hmm.
doubts.
Mm-hmm.
The question is, what's going to take to get you to be able to solve them tomorrow, the next day, and so forth and so on.
Yeah, exactly.
All right, so number 10 here, keeping with doing even numbers only.
Okay.
These are three squares, A, B, and C. They give you the area A, they give you the area of B, and they ask for the area of C.
So you could do, so it would be x is equal to the square root of, well, could we do that? X is equal to the square root of
Well,
the two numbers?
I want you to tell me what you think we should do.
Okay. I think we could do x is equal to the square root of,
Where's X?
there isn't.
You can't make up a variable unless you define it first.
Okay. So we're now A and B, so we could do C is equal to
Hold on.
9.
Remember
Okay.
that geometry problems almost never can be solved directly. We're not going to be able to solve for the area of C without doing something with these two little ones first. Just understand that. That's never going to happen. You're never going to get a geometry problem that says that you're going to be able to do in one step.
Yeah.
Okay? So let's plan on doing it in 2 steps. They've told us what the area of A is. What does that tell me about A?
It tells you that the base times height of A is 9.
More importantly, squares, all sides are the same. So the base and height are the same thing.
Uh-huh. Okay, so it would be...
Does it allow me to solve for anything? If I know the area of that is 9, can I solve for the side lengths?
Well, yeah.
Okay, what are they?
Yeah, 3 and 3.
Okay, that's the key. That length right there is 3. I'm going to write above the line, so not to be confusing. How about square B?
The square root of B is 4.
The side length of B.
The side length of B would be 4.
I would like you to try to use correct terminology.
Okay.
In other words, don't just automatically start out with x equals. Let's examine the problem. What we can solve for, based on the area of this, is the length of each side. So the side length of A is 3, and the side length of B is 4. What's the side length of C?
The side length of C, just the square root of C. Could you say that? Well,
what's the side length of square C? Side length. Not the area, the side length.
Okay. So what is it? Side areas. So the side length.
This S.
Just S. Okay.
That's the side length of a square. They're all all 4 are the same.
Yeah. Okay.
So what is S equal to?
So S is equal to just S squared. Well.
No, that's the area. What's the side length equal to? Remember, in this square C, all 4 sides are equal. That's the definition of a square. It's the definition of a rhombus, but a square is a special rhombus in that everything's a right angle. Okay? But this problem depends on you knowing what the side length is. What's the side length of this square? It's a number, and you're staring right at it.
Just C. Oh.
Length.
Length?
Length is a number.
Oh. Okay. Yeah. Okay. That makes sense. So the length would be
think of having a large cube of building blocks. Okay. You have a building block up here that has a length of 3, and you have a building block right next to it that has a length of 4, and they both perfectly fit on top of this bigger building block down here.
Mm-hmm.
What's the side length of the bigger building block?
4. Well, of the bigger building block, it would be sort of just 5, would it be?
4 is from there to there.
Yeah.
3 is from there to there.
Oh, okay. So it'd be 7.
Okay.
Okay, that makes sense.
Now, what is the area of the square? If it has a side length of 7, in other words, all these s's are 7s,
Mm-hmm.
what's the area of that square?
49.
Okay. So really, that was a fairly basic, simple problem. Very basic.
Yeah.
I'm surprised that it's in this intermediate section, which it is.
Uh-huh.
So we need to go to the next. 6.
Okay.
Yeah, this is still intermediate. Okay.
Okay. Mm-hmm.
And we're still on polygons, kind of.
Okay.
So when they don't give you a diagram,
Mm-hmm.
in other words, most every problem we've had a picture with it, right?
Yeah.
Well, here's a problem about a frame, which is a rectangle.
Mm-hmm.
Let's draw a picture.
Okay.
They don't give it to us. So
Okay.
here's my frame.
Mm-hmm.
Is placed around a rectangular picture. There's the rectangular picture.
Mm-hmm.
The rectangular picture has dimensions 8 by 12.
Okay.
Okay?
Uh-huh.
And the frame is 2 inches wide. So from there to there is 2.
Mm-hmm.
From there to there is 2. That's 2 all the way around.
Okay.
What's the area of the frame only?
Mm-hmm.
Which is a shaded region.
Okay.
Shaded region problems are what kind of problems?
Oh, we did this. Subtraction.
Yes, just always associate shaded region with subtraction. In other words, we're not going to go through and figure out the area of each one of these long, skinny rectangles and that one right there. That'd be the hard way to do it.
Yeah.
What's the easy way to do it? What is the
The
area of the frame? It's the area of what minus the area of what?
It's the area of
Big rectangle
versus a small rectangle.
little rectangle. And it's perfectly acceptable. In fact, I would prefer you start out with this step.
Okay.
In other words, define what it is. In other words, before trying to figure out the area of the larger rectangle, let's make sure that we know what we're doing. We're going to take the area of the little rectangle, subtract it from the area of the big rectangle. That's going to give us the area of the frame.
Okay.
What's the area of the big rectangle? Now we do it step by step.
Yeah, so the area of the big rectangle would be 4.
Give me the dimensions of the big rectangle.
2 by 2 inches by 2 inches.
Really? The dimensions of the little rectangle.
Oh, I'm looking at, yeah. Yeah, my bad. So it'd be, so for the big one, it would be 12 to 8.
That's the little one. And it's not 12 to 8. We're not dealing with similar triangles, or we're not even considering whether we have similar rectangles here.
Yeah.
All we need is the dimensions of the big triangle or the big rectangle. We already have the dimensions of the little rectangle. So the area of the little rectangle is 8 times 12.
Okay.
Okay, but what's the area of the big rectangle? We're not staring that in the face, but we can figure it out easy enough.
Okay.
What's the width?
Um,
What's the width from here to here? That's the big rectangle.
the width would be, you would just see 2 times 2, so it'd just be 4.
No 2 times 2. There's no multiplication going on here.
Okay.
I just want the width. I don't want the area yet.
Alright, it's
What's the distance from there to there?
4 inches.
Is it really?
Well,
Does it look
or,
like
huh?
inches?
Well, it's 2 inches.
Okay, it's 2.
2 inches wide, yeah.
It's just 2. I'm not talking about the area of the frame. I'm talking
Okay, yeah, just the width.
about the big rectangle.
Okay.
The big rectangle is this rectangle here. I want its entire area. For me to get that, I need its width and I need its length. Or I need its base and its height, whatever you want to call
Okay. So it's 2 inches by, well, it's 2 inches wide, and then,
it. Is it 2 inches wide? It's 2 inches wide just from there to there. It's another 2 inches from there to there. How do I get this whole distance?
we could do 12, because, like, it covers the other part of it. So it'd be, 16
There.
inches.
That's 16.
Okay.
That's
Okay.
looking
Yeah.
full time. Now,
Okay.
the area from here to here.
The area from there to there would be,
I use the wrong word. What's that length? It's not an area. It's a length.
okay, the length would be 12.
Okay. So the area of the big rectangle is 16 times 12.
Mm-hmm.
The area of the little rectangle is 8 times 12.
Mm-hmm.
Well, that's an easy answer to come up with. We've done the hard work.
Yeah,
Use
for sure.
a calculator if you want, but let's see. I can do that. I can factor out a 12. I got 16 minus 8, so it's 12 times 8, 96.
Okay,
Area of the frame alone.
cool.
In other words,
Okay.
that's this area of the shaded region is 96.
Okay.
We could have done it the hard way. In other words, we could have gone through and figured out what's the area of that rectangle right there. Then we could have added that rectangle and this bottom one. But then I got 4 rectangles I got to add together. It's just an easier problem to do as a subtraction problem. Big rectangle minus little rectangle.
Awesome. Okay.
And then I screwed up again and did an odd one.
It's all good.
Can't get used to that. That's because I'm not used to doing it. Every time I ever work with these problems with anybody, I'm always doing consecutive.
No problem. All right.
So I kind of like this method better, where we do the even ones in a session, and then you do the odd ones to reinforce what you've learned.
Yeah, I do too.
Okay, we have a quadrilateral. Let's draw a quadrilateral. And let's make sure we do not draw it as a parallelogram or a square or a rectangle, because they don't call it that.
No.
If they wanted it to be that, they would have said that. So we don't want to draw it as a rectangle. It might give us bad information.
Yeah. Okay.
Call that D, that A, that B, and that C. What does this equation say?
It says that A plus B plus C is equal to 2, equal to 2D, basically, yeah.
Okay.
2 equal to, yeah.
So now the question is, does that allow me to solve for D?
Well, it doesn't give you enough information.
Well, actually does.
Does it?
Back and look at this picture here and forget this statement for a moment.
Okay.
What statement can you make up here? All by itself. A plus B plus
plus C
keep going.
is equal to D.
No,
Or A plus B plus C plus D,
is equal to what?
360.
Aha, that's the master equation that applies to all quadrilaterals.
Okay.
Now, what can I replace A plus B plus C with?
Um,
Based on this equation they gave us.
just we can replace it with 1. Well,
What do they tell us? A plus B plus C is equal to.
2D,
So what can I replace it with?
0.5, like 1/2.
2D.
Oh, just 2D. Oh, okay.
You see why? So I can go up into this equation that we know to be true, and
yeah.
I can replace the A plus B plus C with a 2D. Because we know this one is also true. A plus B plus C is equal to 2D. So we're kind of using substitution. We're going to solve this equation with substitution. Okay? And now this equation gives me 2D plus D equals 360. So let's get rid of this so it doesn't confuse us.
Okay.
Well, I can solve that equation. I got one equation and only one variable.
Uh-huh.
And it's the one they're asking about. What's the measurement of D?
Yeah. So we could simplify that to 3D is equal to 360.
Okay, so D is 120.
Yeah.
So,
Oh, okay. Makes it,
so
yeah, it makes it a lot
that's
easier.
basically an algebra problem. It looked like a geometry problem, but it was really an algebra problem. In other words, it was two equations with four unknowns, and you wouldn't think you'd be able to solve that, but if they can give you three of the variables in terms of the fourth, then I can solve it by just straight substitution.
Okay.
It's the first thing you see in this problem.
That there's a shaded region.
Which means, what kind of problem is it?
Subtraction.
Okay. What are we going to subtract? What they want? Well, let's pretend that this is a little harder, but not really. In other words, it involves us to go through the concept. What's the area of the shaded region? Let's start with that.
Okay.
What would area and learn to write it like that, because you got areas of squares, rectangles, circles. The area of the shaded region is what? Going to be defined.
Okay.
Remember, it's got to be a subtraction of something.
Yeah, so it'd be the area of the shaded region, area of the big square, is equal to, or minus the area of the small square.
Actually, the area of the small squares. So it's
squares.
The area
oh yeah, because there's two.
The 3 square minus the area of the 6 square. We could write it like that. Okay? That'll be the shaded region.
Okay.
Okay, now what's the area of the big square based on everything you're looking at there?
Based on that, the area of the big square.
Just look at that big square. What do you see about that big square? They only give you one piece of information.
That the side lengths are 2x plus 1.
Okay, so what's its area?
So it'd be 4x plus 2.
No, don't make that most common mistake made in algebra.
Okay.
2x plus 1, or when you multiply it by itself, it is not 4x plus 2. You're multiplying.
Yeah, so it'd just be 4x plus 1.
No, you're leaving out the middle term. That's the most common mistake made in algebra. Here's the most common mistake made in algebra.
Okay.
X plus 1 squared equals x squared plus 1. That is not true.
No.
You cannot.
Okay.
You cannot just square each term.
Yeah.
Okay? Remember what it means. When I'm squaring it, it means I'm multiplying it by x plus 1. Well, now you have to FOIL these, and when you FOIL it, you have a middle term that comes into play.
Yeah.
So in our case, when I FOIL it,
Uh-huh.
what is that? FOIL that for me.
So it would FOIL.
Multiply it together.
Okay, so it'd be 2x times 2x.
Yeah, ET, ET if you prefer. I never really have liked the word FOIL, but I love the word ET, ET. It means you multiply every term by every term.
Okay.
What does that give you?
So that gives you 4x plus 2x.
No, we're multiplying.
Well,
So first,
so we're multiplying.
multiply that term by that term. What's
So that's
2x times 2x?
4x
4x squared.
squared. Okay.
See why it's x squared?
Yeah, because there are two x's.
Yeah, if I was multiplying 2x times 2, that would be 4x.
Yeah.
But if I'm multiplying 2x by 2x, I got to multiply the x's together also.
Yeah.
So you definitely get 4x squared. That's the first term. What's the second term?
And then the second term would be 2x.
The third term?
And then the third term would be 2x plus 1.
No, just 2x. The third term comes from multiplying that times that.
Oh, okay.
And finally, the last term comes from multiplying that times that.
Yeah. Which would be plus 1. Yeah.
So my answer is 4x squared plus 4x plus 1. That's the area of the big square.
Okay.
Okay?
Okay.
What's the area of the three-sided? What's the area of the square that has a side length of 3?
That would be minus, so it'd be that minus
What's that?
area of 3 squared. So it'd be 9, so minus
What's the area of this square?
minus 36. Okay.
Now, the problem actually gives you the area of the shaded region. It says that's 76.
Uh-huh.
Okay? So, we have to solve for x. Well, I'm now looking at a quadratic, has nothing but x squared and x and numbers. So, I can solve a quadratic like that. Let's do it for practice. That's another thing you cannot get too much practice at, is solving quadratics. I mean, it's solving right triangles and solving quadratics is half of the ACT test. And it's pretty much half what they expect you to learn from math, really. I mean, it's probably exaggerating a little bit, but not that much. Being able to factor a quadratic, being able to solve right triangles and stuff. So, what's my next step here?
Okay, so the next step would be, well,
when you're solving a quadratic that has both an x squared, an x, and some numbers, what are you always trying to, what are you going to do as the first step?
Get rid of the square, x squared.
You can't solve it like that. Get rid of the parentheses. Well, I can just erase those. That doesn't change anything.
Yeah.
Okay. Combine everything. Okay. But the key piece of understanding is you have to get 0 on one side.
Okay. Yeah. So we could do, well, let's add just the regular numbers together.
Combine those three. What do you get?
Yeah. And then you get Uh, so it's, yeah, is equal to 4x squared plus 4. 36, 45, 40, negative 46.
No.
Wait, no. So you do negative 36 plus negative 9, and you get negative 45 plus 1, so it'd be negative 44. Okay.
Now, what's the next step?
And then the next step would be to add 44 to both sides.
Remember, our goal is to get 0 on one side. This is different. Most equations, if they're linear equations, your goal is to get the variables on one side, the numbers on the other. So I can understand why you'd want to add 44 to both sides.
Yeah.
But this is a quadratic equation.
Okay.
Dealing with quadratic equations, most of the time you solve them by getting everything on one side, leaving 0 on the other. So how do I get 0 on one side?
Subtract 76. So it'd be, 0 is equal to plus 4x minus 44.
Minus 76, which is minus 120.
Okay.
Okay? Now, what's the next step?
And then the next step would be, so we have that.
Remember one thing, that factoring this thing is really easy if that number is 1. If it's not 1, it's a hard problem.
Yeah, for sure.
Is there any way we can make that number 1? Can I factor out a greatest common factor that is 4?
Yeah, you can.
Okay, what am I left with?
Just 2x, or 4 times, just 4 times 4, like within the...
Okay, you need to give me each term here. When I'm factoring out a greatest common factor, I'm left over with something. You get it by taking that greatest common factor and dividing every term by it. That's how you get what's left over.
Okay, so it would be 4 times, just 1 over 4.
If I write 1 over 4, does that give me 4x squared?
No.
Okay, so I've got to write something in there that when I multiply it together again, it's 4x squared.
Okay.
What would that be? Okay, let's do it the hard way. There's our 4x squared. We're dividing it by 4. What's the answer?
Just x squared.
That's what goes there.
Oh, okay.
You have to do it this way, do it this way.
Okay.
Okay? If you should have, in addition to a calculator in front of you, a pencil and paper.
Yeah.
So that when I ask you these questions, what's left over, you can do it however way that allows you to do it.
Yeah.
You don't have to do it in your head. You can always do it however way that gets you the answer. The important part is this. After you've done it, always do the check immediately. I do every single time. I never write this down without in my head multiplying it back together again to make sure that I got what I started with.
Yeah.
That's why when you gave me the answer 1/4, well, when I do the check, 4 times 1/4 is 1.
Yeah, not x squared.
Give me that. So make sure that the moment you write down that answer, you remultiply those to make sure you didn't change it.
Okay.
What's next?
And then it would be, so 4 is equal to x squared, or 4 times x squared, plus 4x minus 120.
Hold on. Is 4 times 4x that term?
No.
Okay.
So just
go back and
times x, or plus x.
There you go.
Okay.
Always do that check. Don't just write something down and go on. Because you're not going to be able to catch your mistake when you're done. After we get down to this bottom where we have x equals something, and you've made a mistake in one of these 5 steps, you're not going to be able to catch it. The way you
Yeah.
catch mistakes is by checking for them at every step of the way.
Okay.
What's the last term?
And then the last term would be, what goes into 120?
What
120 divided
goes
by...
into 120? Hold on, we're not factoring yet.
Oh, okay.
All we're doing is dividing this by 4.
Oh, okay, so it'd just be minus 30 then?
So, this here is exactly the same as that there.
Okay.
And that's what's important. I do not want to change it. I've changed it, I've made a mistake. Okay, now if this all equal to 0, what's the next step?
And then the next step would be get rid of the parentheses.
No, we just put them in. We started without parentheses.
Yeah.
We're trying to make this a quadratic that's easy. Well, there's a pretty easy quadratic, but I can do something with this 4. What can I do with the 4?
You could divide.
Okay, divide both sides by 4. What are you left with?
You get 0 over 4.
Which is 0.
Yeah, which is 0 is equal to x squared plus x minus, yeah.
Now it's an easier problem.
There we go.
Isn't this far easier than that to factor?
Definitely. Yeah, definitely.
Factor. This is an easy one to factor.
Okay. So it would be 0 is equal to x squared, like in the parentheses, x squared.
Go back to your factoring. How do you factor a quadratic?
You put, yeah, like parentheses, and then
It's a 3-step process. Actually,
yeah.
4-step process. And if you don't know what each step is, you need to write it down and memorize it.
Okay.
First step, separate the x squareds.
Yeah, so it'd be x, and then in the parentheses, yeah.
That's step 1.
Uh-huh.
Okay, write it down. Step 1.
Okay.
Step 2, determine both signs. I'll get through this quick. I know it's 11:30, but
Okay. No, it's all good.
this is important to cover here.
Yeah, for sure.
Determine both signs. In other words, what is that sign going to be and what's that sign going to be?
Okay.
What does it have to be in order to produce a negative 30? That tells you something about those signs. They have to be something.
We could do x minus 6 and x plus 5.
Well, okay. You did steps 2 and 3 at the same time.
Oh, okay.
I really would like you to do it one step at a time.
Okay.
The signs. You got the signs correct. The signs have to be opposite. It doesn't matter whether I put the minus here and the plus there, but they have to be opposite because that's the only way that you can produce that number. When I remultiply these back together again, the only way I'm getting a negative 30 is if one sign is plus and the other is minus. Okay, now you got it right. I'm looking for factors of 30, 6 and 5, that subtract because of that minus sign. Coefficient 1. Well, perfect. 6 and 5 subtract to the number 1. But now I got to figure out where the 6 goes and where the 5 goes.
Okay.
The larger of the factor goes with the sign of the middle term.
Gotcha. So it'd be x plus 6 and then...
Yeah, you were close. You had x plus 5 times x minus 6. So these are very simple. They are 4 steps, max. You can't do it in 4 steps. You need to use the quadratic formula. But they're very easy to do. Let's get proficient at doing this. Because this has to be done also. We can't escape factoring the quadratics.
Okay. Yeah.
All right. Dylan,
awesome.
I will talk to you at 10:30 in the morning.
Sounds good. I'll see you then.
Building up to going back to school, huh?
What's that?
I said you're building up to having to go back to school. What time do you have to get up to go to school?
Oh man, yeah, we have to get up. I have to get up at 4:50 because we have baseball before school every morning.
Goodness. Oh my goodness. So you're not building.
Yeah.
You're building up
No.
to a 9 o'clock session tomorrow and then a 7 o'clock session on Wednesday. But
Gotcha.
no. Okay. I'll see you at 10.
Sounds good. I'll see you then.
Get some sleep. Sounds like you're going to need lots of it.
Yeah, definitely. Oh man, that's what the weekends are for. So
All right, Bill. I'll
awesome.
talk to you in the morning. Bye-bye.
Sounds good.